Oh, there, I'm live. Okay, well, since this is a recorded video, I'll just kind of give an intro. I'm Greg Tatum, and I'm giving doing a demo of Three.js live coding. We'll see how this goes. Okay, so to give you a little orientation, I have this project called Sandbox, and it's very opinionated, and if you start doing Three.js stuff, you probably don't want to use my sandbox, but I like it because I can reuse stuff really easily. And so it's a quick way for me to get going. If you go onto Three.js, I have my local host because I added some stuff last night because I'm really kind of showing some new examples. But if you go on here to the docs, you can see like creating a scene. And let me make it a little bit bigger. And it's just like, the code's not very sophisticated as far as like a lot of demos go. It's very spaghetti code. So I'm using Browserify with modules to kind of make that process a little bit nicer for me, more reusable. And so I have some like actual modules that I've created. But you can see like, if you're getting started, just follow some of this boilerplate and your structure can come later after you've learned it to work into whatever your style is like. But you can see like, it's like create a new scene, camera, you add it, make a renderer, you set the size of it. It's just kind of boring a little bit on like some of the basic setups. I'm going to skip over some of this pretty quick. And then you create basically geometry, material, and a mesh. And then you add it to the scene. And then you can move stuff around through the properties. And I'm going to gloss over some of this so you can just read a tutorial if you're really interested. In the render loop, and so there's like the basic hello world. So do that after this if you're interested in like that side of it, but I'm not going to go into all that. What I'm going to go into is, so I've got these different modules I've made. This one's called Poem Manifests, and it basically reuse visualization code by creating levels for manifests. And so I'm going to kind of use this to drive some of it and then dive into some actual code. But I'm just going to demo some things that you can do with this. And then I'm using like a poem loop, which I made, which is just kind of a layer of opinion on top of the animation loop, and then I have a poem menu that takes a manifest and makes a menu out of it. And so this is just some boilerplate, so I can like quickly prototype ideas without having to make the same code over and over again. So right now you can see these are all my kind of levels I have. I have a few commented out, but you can go here and load them up. So this one's like a video I projected onto a sphere. So it's kind of a nice little system. But for our purposes, I'm going to start over to spheres. And I'm going to comment those out, and hopefully that works. So I just did that, so it just loads a little bit faster. It's not loading all the rest of the stuff. And I have just to show you how I'm running everything real quick, I've got this command right here that runs Beefy, which is a small web server that auto-injects your script, your browser-fied script in. So it's a quick way to prototype ideas without getting Gulp involved, and stuff like that. And so that's running and should do live reloading. Hopefully that won't break. So yeah, let's get started. So this is the spheres, and it's loading in this file here, which this is my manifest. And so you can see this is kind of like the name, description, all that kind of fun stuff, the order it's in the menu, the configuration for the scene, and then my components, which are reusable things. It has a name, and then it has either a constructor or a function that it calls, or it's just properties, which I forget the designation for that. You can see here's my spheres, which I can kind of control some high-level stuff from it. So if I want to add a few more, I can do that. Put up 100. I can change how much they disperse. So let's do like 200. So kind of nice, easy way to kind of control your code. So we'll keep this a little less so that my computer doesn't get too hot to start out with. So basically what I want to do is kind of play around with this and see what I can kind of come up with. So this one does actually some raycasting, which is some weird math stuff. So I set this up last night, So hopefully I won't get too confused if I'm using it, because I'm not like a raycasting expert by any means. But it gives you a little bit of a chance to interact with things. And so diving into the code, let's see here. This one is the JS demos spheres, so load that. That's just the file. You can cut off a little. You guys read that in the back just fine, or is it? Okay. So to collapse this, just to orient you guys on what's going on. So create spheres is my function that gets exported. So this runs whenever, like, and it gets the poem, which is what I've named my central graph. So this has access to the camera. So any component I name here, so components, controls, mouse, grid, spheres, that all gets set onto the poem object. So I can kind of get access to it if I need to. And then I get properties, which those are what get brought in. And then I set a config that kind of sets defaults, and I configure all my functions. You can see here I create geometry, which is just a sphere, a basic material, and then I have a function that creates an array of meshes, which meshes are the objects you add and you interact with. Then I get access to my mouse, which is I basically configure with a reference and get a copy of it. It's like another file somewhere else. And then I have a Brownian motion function and a raycast, and I basically have an emitter for my poem that I do an update with. So this is like a lot of structure that if you're just getting started, you're just going to ignore and just kind of hopefully we'll get into some more imperative code that says exactly what we're doing. So right now I have a Brownian motion thing. So I want to kind of adjust it. I don't know, make it a lot more aggressive.
They have a seizure.
Yes. If anyone has epilepsy, tell me now, because I can't see what's going to display on the screen. That one's much slower. But you can see right here, I'm just looping through my meshes. And this is a function that returns a function. So this function is what runs the loop, and I give it meshes, kind of my dispersion amount. Let's go back to where that was. So you can see it's pretty easy to do. We just do meshes, go through them, get the position, X, Y, Z, and play around with the values. And it moves it in 3D space, and you can rotate around and look at it. So let's look at create meshes. Hey, Luke.
Hey, Luke. Hey.
Actually, we're going to do some geometry stuff because the spheres are kind of boring. So let's do this. I don't know if I have any lights in here or not. We'll do the Lambert material and see what happens. So I don't have any lights. So Lambert material actually uses lighting to do some shading on it. Basic is just a single color. So I'm going to go in here and I'm going to cheat and load up my carbon dioxide earth and then do copy and paste over here, the spheres. And my library load broke, it looks like, I don't know. Let's try it again. Oh, there we go. Now we got a little lighting. And I loaded in some lights that, basically, if you've ever done any lighting, like artistic style, this is a 3-point lighting. So it's got a fill, which kind of, if you have a sphere, it hits one side right here. And you have an edge light, a rim light rather, that comes on this side, and then like a fill light down here. A lot of times you do them slightly different colors, but it's red, so it doesn't really show the different colors on it very well. But you can see they have a little bit more shading, so you can't really see on this one. So let's make it a little bit darker. So I'm going to go back to my spheres, change this into something a little easier to see. Why show up? I'm just fiddling with values now. There you go, cubic green. All right. Oh, and the glow on it, I have some post-processing going on, and it's just part of my engine I built. Like I can turn that on and off. Okay, so let's do something different. Let's look up a geometry to use. So I think the spheres are boring, so I'm going to pick there's one of these. Yeah, tetrahedron. So I built this little thing last night to visualize the different geometries, which I've built some of them for Three.js for like the materials, and I like to do it because it's easier than typing in code. It's just you go in here and it's got a little control. You can see what it does. So this one's a tetrahedron geometry, which is kind of cool, and you kind of see like the structure of what it looks like. So I'm gonna pull this one in, and configuration on this is pretty simple. It's just a radius and the amount of detail. So those kind of look a little bit neater, so let's do that. And detail will be 0. Which, that's kind of, they're all oriented the same way, so it looks kind of boring. And right now it's smooth shading on. So smooth shading for it, just like smooth, like, it has to do with normal calculations, which I probably won't go into, but it doesn't look so good. So I'm gonna change it to, I have to look it up, because I forget this. Go to mesh, Lambert, and there it is. So mesh Lambert, I'm going to expand this out a bit. I'm going to add more properties to it. And shading is black shading, I believe. Let's see what happens. Yeah, there it goes. So you can see it's not quite so smooth. You can see the hard edges of it, which is what I want. And they're all oriented the same way, which is boring. So I'm going to add, I've got this create meshes function right here. We'll dive into that, which is up here. And this is just going to set a random position, and we'll set some random rotation on it, which we just want to do a math.pi to math.pi. So this function just generates a random range between those values. So generally rotation's all in radians. There we go. I got them all randomly moving around. So I think it'd be cool to make it be attractive to the mouse rather than just going up. Or maybe, actually the Brownian motion kind of is stupid. So let's add a random, I don't know, let's add some velocity to it so that they actually kind of are attracted to something. So I'm going to break some rules, coding practices, and just kind of add some data to this mesh. We'll call it a velocity. We'll make a new 3 vector, and we'll set some random values. And I don't know. How fast should I make it? Anyone going to throw out a number?
3 million.
I don't see anything.
Yes.
The units we're dealing with on this version are about 10. So this is 16. This is 60 frames per second. So 10 divided by 60. Oh, what's that? Some zeros. Let's see what happens.
That's boring. 3 million.
And config.velocity
times 3 million.
times 3 million. Config velocity. Right. It shouldn't do anything yet. So now I've just saved that data to the mesh, so that takes it with it, which is kind of nice. I mean, it's modifying an object that you don't have a lot of control over, so it's a little brittle, but meh. So I have the basic velocity set. So now I just need to, I'm just gonna create a new thing called, I'm gonna copy Brownian motion and call it physics motion. Sure, why not? And then I'm just gonna copy this. Comment that out. And then physics motion. So now that broke. Why would that break? And live coding for the win.
Because your hatred of semicolons.
That is probably. Actually, it's gonna be really fun if I do get a semicolon bug while I'm doing this. 105. Oh, that's why. It's multi-line. Not a semicolon issue. Not yet. Okay, now I have Brownian motion. So rather than doing a random that, let's do mesh dot velocity. Which I could, there's a function to do this like without 3 lines. I just don't want to look it up. And this e.dt is essentially whenever you're going through a render loop, if you don't multiply it by time, if the timing between the frame calls, like it makes it feel staggered. So it's just a way to kind of smooth over the motion, but that can introduce other errors that take much more engineering to fix. But that broke. Oh, I did mesh. But essentially right now I want to look at, I forget what I called it, but I want to use unit dt. And I don't, there's a thing called unit interval, which is between 0 and 1. And so I call stuff unit something or other to say, hey, it's between 0 and 1. Just a style thing I do. So I'll do a unit change in time. So that way I don't have to think about multiplying by 16 or whatever number it is. Yes, nothing. Let's just do this.
One of them did something.
Well, that thingy. I don't have that open, that's why. So I'm just going to inspect it, see what's going on. Maybe it's just too low of a unit.
3 million.
3 million.
You thought it was a joke.
Oh, that's because multiplying by. I don't know.
Oh,
We'll see.
you were multiplying by unit. Some kind of units, right?
Let's bugger in there. Aha!
A little bit, but yeah.
So let's speed it up. Now we have motion. And let's bring that unit dt back. Okay, now they're flying off into space. Awesome.
I can go faster, right?
Okay, let's add a target now. Faster. How much did you say? 3 million? Oh, no, that's the zeros in there.
See a blank page.
Yeah.
They're gone.
They're gone.
They're very, they're very gone right now.
So, okay, they just disappear now. So now we want to basically linearly interpolate between the velocity and some other value. So we're gonna add the target now. So we're gonna go back up to here where we create the meshes, and now we have the velocity. So now let's add a target. We're gonna set the target to how about center? So target.
You want to follow the mouse. You say when to follow the mouse. Is it that easy to just say the mesh target?
You can have multiple targets.
Ah, okay.
So we're just gonna try to keep it on the screen right now.
You can't contain 3 million.
Have them all raised at 3 million parsecs to your mouse.
So meshes. I don't know why I'm doing meshes I. So if you notice, I have a for loop in here rather than a functional thing. Voodoo tells me it's faster. So, and if you do like a lot of those, what's it called? The where you profile functions to see if they're faster. What's that website?
Yes.
Perf. Yeah. A lot of times those lie because they're not real world use cases. They get the compiler does things funky if you're not actually using it. If you're using it in a tight loop. So those sometimes lie to you on how fast things are. But people, I haven't tested it, but people say that this is faster to do with for loops, and they're very vocal about it. So I'll just go to that real quick. And then we want to do a mesh position. Now we want to do mesh velocity. I'm modifying the wrong thing. We want to forget how you do this. Well, if it's a lerp, linear interpolated means move a little bit towards something, which I'm going to look up because I don't remember. Vector 3. This lerp takes a vector and an alpha of how close to move towards it. So we'll do the mesh.target with times e.unit.dt. There we go. So we're going to move the velocity towards the target. Nope, that's not what we want. We need the so if you notice, I'm allocating some memory here. I'm creating a vector 3, but I do it outside of the loop. That way I'm not allocating memory within the loop. And then what I want to do is I want to take the difference between, what is it? Subvectors AB. Let's subtract the mesh.position from the mesh target, which is the difference between them. I'm trying to do the gravity formula right now off the top of my head, so we'll see if I can do this in front of people. And then we want to take that and make a unit vector out of it. So it's going to have length 1 if I normalize it. And what I want to do is then, here's what we need to do. I need to normalize velocity as well. So velocity is actually technically direction, which we will call, we'll just do this. Normalize. So things that are unit, that are length 1 are very, very helpful in visualizations. And I saved it. So we'll see if it. So we'll take this and we'll do the scratch. You see they're all zooming away from center. So let's do this, switch it. Now they should all go towards the center and quickly collide. So what's happening is they're turning really quickly. So we want to slow down that turning. So if you notice, this velocity is basically,
I can't even tell what that function is.
lerp.
Dash dot velocity dot what? Lerp?
Lerp stands for linearly, yeah.
Okay.
Linear interpolation between this vector and v, vector v, where alpha is. I didn't write that right. What's really funny is like, if you write the docs and you go back to read them and you're like, what is this? Like, I knew what this was at one time. I think the math stuff was the first stuff I read because I was like, what is on this graph? So let's slow down. Too slow. That's kind of funky. So this is where it gets fun. So you can start playing around with it, with doing random stuff. And it's got a little jitter to it. I don't know why. And it's weird, like you have to like make sure that your floats aren't like have enough precision with whatever kind of units you're using, because they floats only can hold so much value. So if you like get too close to extreme values, then you get funky things that happen, like jittering and things like that. So right now what we don't have is a speed for this. So what I'm going to do is add, oh, we do have a velocity. But the thing is that we don't need this here. We just need this between. So essentially right here I do mesh velocity. I set it random velocity, and then I normalize it. So it doesn't matter what these values are as long as they're non-zero. So I'm going to take all these and just set it to 1 and -1. And then this one has dispersion, which we don't care about. So we're going to rename it to velocity. And take this velocity and feed it in there. And we're going to do times velocity. So this is all like vector math, which if you're going to do 3D stuff, like this might seem like voodoo a little bit if you're not comfortable with it, but that's what you need to get really comfortable with, and playing around with it is a good way to do it.
That book you told me to buy on Facebook, forgot it. It is awesome.
Sweet. The like game engine architecture one? Yeah, that's like one of the best books I've read.
I'd be so lost. I read a chapter about linear vectors and multiplying and dividing and subtracting all the vectors. So that was really cool.
So right now I don't have good controls for like controlling behavior, and I've named velocity wrong now. So mesh.velocity is a bad name because it's not the velocity, it's the direction. So I'm gonna refactor real quick and change all these to direction, which hopefully I got them all and it doesn't break. There we go. And then we want a turn speed, which this is basically turn speed here. The interpolate, when you move between the direction of the, if you move the direction towards your target, that's its turning. So this one's 0.1 right now. So we'll do turn speed. That sound right? Okay. And here we'll do turn speed. And we had 0.01 before. So let's do 0.05 because I want to turn it down a bit. And then feed it in. Or I could just do feed in the config to it. I'll do turn speed. Yeah, that's a little bit more interesting. Yeah, that's more fun. We'll make the. It's going to settle in on the target. So we're going to make the velocity faster. That's boring. Holy cow. That's kind of funny. Oh, man. So this still, like, I can still kind of mess with this a little bit from my, I have the Raycast function. So maybe I don't need it that high. Here, I know what we should do. So it's boring that they all collect right there. So maybe let's add some motion to their targets. Just eventually they'll wander off the screen, but it'll at least keep it interesting for a little bit longer. So the brownie in motion, if that seems to have something to do with it, I'll just add target sure.
Can you set what if you set one to have its target be like whatever the preceding one was in the meshes array, so that they start just chasing each other around. So one is always trying to chase another one, and that one's trying to chase another one, that's trying to chase another one.
Yeah.
That one is chasing, if you say the target equals, its target equals meshes I minus 1, like the mesh at I minus 1.
Who was the first one called?
No.
You make it random.
The first is loop around.
There, no, they look like they follow it.
So what was I doing? Let's undo that. Yeah, let's do that. That sounds fun. I really like that idea. I have no idea what it's going to look like. This is usually what makes me go to bed really late. This is like, oh, I have to do that.
All right, I'm out of here.
Okay, so I need to set the target to the meshes I minus 1 if I is greater than 0, right? This is Philip. He works with me. That's right, right? Target equals the position.
Yeah.
And then at the end, we need to do the meshes. Meshes 0 target equal to. Will I be? Will I need to do that? Yeah, I think so. Position. Is that logic right?
You do I plus 1, so it's just following the one that's following it, and then all of the others are following the two of them. Is that what you did? I can't tell.
Wait.
Okay.
It's not going to get I if it's outside the loop.
Yeah.
What? No. It'll still be in scope,
Okay.
I think. Anyway, I can just do here. I'll do it differently. This way, I'll let it work. Meshes.length minus 1, the end one, right?
Oh, okay. Yeah, that'll be fun.
Oh yeah, it'll still be set as the last one on it.
Oh, I have fog turned on. I should turn it off. Let's set the speed lower. It's live reload working. I never turn on live reload.
You can see, you can see every once in a while, one of them makes a move for the other one.
Let's make it more aggressive. So
Wait, let it go for a while. I want to see if it turns into eventually like this keystone cost. Like,
It looks like they're going the radius.
Let me-
is bigger.
Let me turn off the fog. If I remember how. I don't.
It kind of looks like a low budget version of Star Wars.
Oh, I guess I can do it on the material. Fog false. Let's do that. Fog is part of the shader, and when it does the shading on it, it kind of turns it into a color. So you set the fog color the same color as the background color. It looks like it fades away. Match Lambert. We'll do fog false. Hopefully, still be able to see them whenever I zoom out. Yeah. Which I think we need to make them turn towards each other quicker still. So I like to double values or like doing like an order of magnitude higher.
10 times.
Yeah. There we go. That's more interesting.
Whoa.
Now that's funny.
It's like a double. But it's slowly changing over time. Like the shape like quickly goes into a chase, but then that chase gets a little bit different.
So if you're thinking in terms of physics and in terms of visualizations, visualizations are noisy in two different ways, typically. The precision of floats aren't 100%, so your math's going to not be, like this loop's going to break eventually, it's going to move around. And I have this driven by time as well. So time is basically indeterminate rather. So it can change how everything works. Okay, well, since how many of these? 200? Let's add 1,000.
200 spheres? Is there 200 spheres in there?
Sorry, 20.
Oh, okay. Whoa.
So it's still running, that's good.
We go until the computer crashes.
That's usually what I do. Yeah, late at night my lap gets hot. Abusing it.
Great. The singularity.
There you go.
Yeah, so I got something going up here.
It's even patterns.
This is fun. I like having other people saying, "Why don't you do this?"
So who brought the mind expanding girl?
Yeah.
Bring your own like
Okay, let's make some interesting stuff happen. I uncommented some stuff I had in there. Might as well do this for a second. There we go. See it full screen. It's like a whole bunch of,
Yeah, it's funny to watch loops form and then.
yeah. A little lag there, but not too bad. Let's add one more on the bottom. So we have two clouds. Might as well. At the bottom, height is -1,000. Rotation, you probably want them to be slightly different. See if that breaks anything. Comma. Oh, it's rotated to the side.
It, yeah. Can you? Yeah. So now it's not a top and bottom.
Oh, you know what? It's because I think it faces a certain direction. So polygons are typically one-sided.
So they can stay the same rotation.
But there's a way to rotate. I don't remember how I built this control. Let me see if I can open it and look real quick. Offset, that's what I want. Let's see here. I want this one to be something funky-ish. I'm just making up numbers.
Oh, that's high school.
There you go. I think that's better. This is very green.
I like the soundtrack with it.
Yeah, it's appropriate. Well, that's actually my other one I left uncommented in there was a music. It doesn't read the audio. I haven't got that far. I'm going to eventually. Because I want to do this, but like with the DJ. Like to start coding with the DJ. I think that'd be pretty sweet. And having like build a whole bunch of stuff, you know, you can pull in and just start playing around with this. Yeah, why not? That's actually really cool. Actually, the trick now would be to make them orient the same way as the But I think that's too much vector math for being in front of people.
What about changing their color?
So right now they're sharing a. So this is an interesting point. Whenever you're so what Three.js does really well is it abstracts tough WebGL stuff from you. The thing is that only goes so far, and this is sharing one material. And it tends to get slow really quick. But what I could do is I could set the vertex colors for each geometry. And there's like funky stuff that probably would take me longer to do than a live demo, which we could do. But I'll leave this to a pull request from one of you. See what else we can pull in here. I don't know if there's any other funky things. Grid, stats, controls. Could add stars. I think I have a stars one in here somewhere. There we go. Stars. Are there stars? Did they show up? I don't see it. Reusable components, they're great when they work. Okay. What else should we do? Because this is pretty cool. I kind of just want to do a...
Collision detection. That's easy now, right?
Yeah, it's super easy.
Yeah, it's doable. If a chaser gets close enough to one, have that like swing the one.
Oh wait, I have a mouse that works. I forgot about that. That was like, I spent like a good hour setting that up last night. Okay, I just wanted to commit that because it was cool and I don't want to lose it. So we have a mouse. Let's dial this back in so that I can see what's going on.
3 million?
3 million? Or do you want to see how many zeros I can add? Let's say we did 1,000. Let's make it a little bit more performant by getting rid of the effects. I have 2 going at once. So you can see the difference here. This is without oh god. Yeah, I warned you about seizures, right? So that's without any of the glow effects and things like that. So you can see that like the different feel it has. Less, it's a little bit softer when you use effects. See, that's way too many. Oh, you know what we should do? Let's put gravity back in. Let's put another attractor in there. That'd be fun.
What, Z gravity?
We'll do that makes my head hurt. I need to turn that down.
Variable speed on them.
Variable speed. Okay, we'll do that. That's a good idea. That's a real good idea. Then they'll go shoot past each other.
Yeah,
and just have to go back around.
Actually be able to catch
They'll catch each other and then
We'll go back down to 20 because that seemed to be pretty easy to see what was going on.
what are you talking about? I'm following.
There we go. Yeah, that's a lot better. So how do I have that? That's a velocity on the config. So we'll do mesh dot velocity equals random range from, let's do config dot velocity times 0.1. You know, it's rather than like putting a random value like a 0.1 in there, I put in a fraction of it. So that way everything's driven by the values I put in and become a lot more interesting that way. Because then if you go like, you might assume you're going to be within this range, but you start dialing it up and it gets more interesting. So got the velocity now. Let's go ahead and clean this up to make it so I don't get confused later on. And the mesh stuff velocity.
Oh, they're catching.
Break them apart a little bit. Okay, so we just made them different speeds. Let's, since that didn't, like that's boring. Let's just make them a lot closer to the same speed. And then try that one. Let's get a little bit more interesting. So I have this random function. And actually it's really cool if on certain things you can do like a pseudo random number generator so it's repeatable so that the randomness will be the same every time and you can seed it with different values. And if you if you do like your configuration values with the randomness and then like try to dial in some interesting configurations, you can basically just reload it several times and like throw in different random values, and it's really cool because I'm working on this generator that is using that, and it's really cool. But I've got some things that are like range low and range high, which basically just multiplies random by itself. So it's going to be either lower or higher statistically. So you can kind of adjust things that way. Okay, what was the other suggestion? Wasn't there another one?
I said when one catches, which now is possible, like at variable speed. But if it catches, then if it gets within a certain distance of the one that it is chasing.
Oh, but see, that's a big O(n) squared problem. So it can slow down your stuff really quick because you have to be aware of every other thing in there.
Well, that's good, yeah.
Well, ends up being processor speed.
Can you make it like every 3 seconds change who you're following to a random?
Yes.
Random minimum index 0, random max index.
We'll do it in physics motion. So I'll do it if a math random is greater than 0.9, I don't know, what, 8? We can dial that in later. A lot of times I'll write this stuff and then like take all of my scalar values and collect them all in the config, even if I don't ever plan on using them. Then they're in one place and I can like fine tune my visualization pretty easily. So we want to change the target. To equal So I want a random, you know what? There we go. Pick a random one. I have underscore in here, I think. It's either underscore or low dash. So this is a function that will pick one random. Wait, is it pick or is it sample? Let's look. Yeah, sample. Okay, sample one and then get its position. They stop if they have to follow themselves. So I think their turn speed's too quick. It's more blobby. Kind of interesting. Okay, now let's do some raycasting. So here's how the raycaster works. This is weird stuff. Like this is math that I can step through and sort of understand, and there's going to be some like matrix transforms in there. So luckily they have this raycaster thing, kind of abstraction of that. This is my mouse range that it works on. And basically I take my raycaster and I set it from my camera and my mouse, which I pull in. I'm not going to show you how I get that in there. And I have to get my mouse into a certain like -1 to 1. So the center of your screen is 0, 0. And then, so I get a mesh and I get the distance. So I raycaster ray, I get the ray from my raycaster and I get the distance to point. Because most of the time you just want to like know when you're like doing a mouse over on an object. And so the raycaster lets you do the mouse over. It does all the math for you. I wouldn't say it's very intuitive every time I've done it. It'd be nice if you could just say install like npm module this and then it works. But maybe this is out there, I don't know. Or maybe I should build it. So if distance is less than range. So basically right now what I'm doing is this function takes the distance and then it moves it up like the closer I am to that point. So I make my range a lot wider. So you can see it, it's just moving it as I get closer to them.
Now, what's the camera part of that? How does the camera
That seems really small now. Where's my camera component?
Well, not necessarily how to, but how does the camera get a camera position?
So the camera is a Three.js object that you interact with like any type of mesh. But all it is a matrix. So I think there are a series of matrices. There's a frustum matrix. Not frustum, frustum. Which looks like, basically, that's really small. There we go. It basically translates your points into like a view. Essentially, you're translating all the geometry on the screen into a homogeneous space, which is from -1 to 1, like a cube. And so you're taking all your points and then moving them in that homogeneous space and then rendering it all down into, basically you're taking that cube and you're flattening out into the image. So this basically is the way you do that. Yeah, it's
something that's this far away and make it look like it.
And give it the perspective where it looks like it's going in. Because basically it takes all that stuff out there and then shrinks it in for you. So essentially you have to take a ray from like right here. So let's say if you want to raycast from your camera and my mouse has moved anywhere on this square right here. It's basically projecting a ray from right here to that point in the frame. And then it's going out and it's seeing if it intersects with an object. So And it's almost been an hour, so I'm gonna try to wrap up with doing something with this. But I'm not sure what I can do in a few minutes. Because again, you're getting into vectors, which can be confusing, and you have to think about for a bit. So what I'm going to do is, if the distance is less than the range, rather than adjusting the position, I'm going to set a value. So the mesh dot, what are we going to call it, flee, dot set. I'm going to set it to, how fast are we going? Let's just say, I'm going to just dial in a value rather than do a config value. I'm going to say you're going to flee at, we'll do a single scalar value. That'll be easier to see. So basically what I'm going to do is when you get close to one, I'm going to make it zoom out of the way. So I'm going to set flee to set flee to 1 for all of these. So essentially it's either going to be 1 or it's going to be 30. And then I'm going to ease back into 1. So during my physics motion, I'm going to say mesh.flee equals I hate this math, so I'm just going to do this. Really lazy. We'll see if it's installed. If not, I'll install it. Lerp between mesh.flee and 1 at a speed of 0.1. And then my velocity, I'm going to take my mesh.flee and multiply that by my velocity. And then find my, oh, that's because I don't have the module. Which I have it at 300 still, don't I? See if that works. Okay, so that's a little fast. Let's see here. There you go. That does something.
Yeah, there.
Actually, what I could do is,
You set the camera to the position of one of those meshes, it would look like.
Can you
and then you'd vomit.
Can you attach the camera to one of those meshes?
Yeah.
And just make the camera like this?
Yeah, I'll do that here in a second.
First-person shooter view.
Oh God, you're gonna vomit. So I want to move from the flee position towards 30. So that's too quick. Like I want to ease into that motion. And then we're doing it at 0.1. So if you know, it's like when you set something immediately, it like it changes really quick. You don't want to. You want to ease into motion because that's like what feels natural. So linear interpolating between them makes it smooth. Let's slow it down a little bit. And then change it from 30 to 15, which I should have put all these on config, but I was running out of time. So, that any different? Yeah, that's a little better. Sweet. Now we can actually kind of, sort of, interact with them. Let's dial it back up. let's make it fast, but happen slower. So I'm gonna make the ultimate velocity really quick. That's happening way too fast. Is it that way? And that one I really should multiply by the time difference, change in time. So double it, multiply by 5, and then that would probably be good enough. Now that one's cool, so we have to add a whole lot more to it and see what it looks like. I like to joke that I make a loop and just like start increasing it, because that's usually when interesting things happen. All right, full screen. So yeah, that one needs a little bit of adjustment to be interesting, but so yeah. Anyway, I won't take up too much of you guys' time, but I hope you found that at least kind of interesting. I don't know.
Yeah, definitely. Is this on GitHub?
Yes, I will push I'll commit all this and push it up there. It's under my sandbox, which is like, it's a lot of junk in there. And I actually committed a big video in there one time. So
It's gonna be one.
So it'll be a little bit of a download. I really regret doing that, but I wasn't. That was that Earth video.
Are you the only one committing to the Raybook? We can totally rewrite history. Let's do it.
That sounds so scary. Yeah, I don't even know if anyone started. Actually, I think like 1 or 2 people have started. But I usually like, if I'm going to demo something, I do that, and then I have it on my website. It's like if it's interesting enough, I'll separate it out and turn it into its own like thing. That's how my tree growth thing started, was in this, and then I pulled it out. But I try to put everything into modules so that I can use components and everything else. So yeah, hopefully if you're interested in messing around with it, I mean, we've gone through the code enough, I think you can kind of mess your way through it.
What was that tool you used to, where it was reloading the browser?
It's called Beefy. Do you want to go to Thunder Plains? One of the speakers there built it. I forget his name. He gave a very hardcore talk. I missed it. Like, I was really mad. But what was that guy's name? Yeah. Thank you guys for coming.
Yeah, thanks. That was awesome.
Stop sharing. Oh, good. Now I'm back on Hangouts. Now I have to. Oh, hi everyone. Stop broadcasting.